This video is about radians. This video is about radians, and I want to start by talking about circles. So let's draw a circle. And in a circle, one of the things you have learned about in the past is the definition of pi. Pi is the ratio of the circumference, distance around the circle, divided by the diameter. And so if you have to find circumference, that's multiplying this formula for pi, definition for pi, by diameter on both sides. You get circumference is pi d. And we know that pi is about 3.14. We'll just use two decimal places, about 3.14. And that just means that if you look at a circle, you take this diameter, and if you were to wrap it around the circle, you get that you could do this about, I don't know, something like that, maybe 3 times about to here, and then this little final piece right here is about 0.14. It's a little over 3 diameters. If we wrap that around the circle, that gives us the circumference. So if I have a diameter, say, of 1 foot, then the circumference is about 3.1 feet. Simple enough. Well, radians don't use diameters. They use, or radians, we use the concept of a radius. Makes sense. And so another formula for circumference is pi times, and instead of diameter, 2 radiuses. So what we're talking about here, let's draw another circle. We have a radius. That's our radius. And we can say a radian is the arc length. A radian is 1 radian is 1 radius wrapped on the circle. That's about 1 radian. And the nice thing about a radian versus degrees is it's not really arbitrary as far as like degrees are. 360 degrees comprise a full rotation, but that's got a history that goes back to even the Babylonians that relates to the number of days in a year and their number system, and a lot of history there, but it's sort of arbitrary, and it's stuck with us. A radian is a way of measuring an angle based on the circle itself, and so its definition is the arc, or the angle subtended by this arc that is 1 radius long. Now that radius is a straight line, but this arc is obviously curved, and so it's a little less than 60 degrees. If this were a straight line equal to the radius, then it would be 60 degrees. But it's really about 57 degrees because we're not traveling in a straight line. Hope that makes sense there. Now, 2 radians then is about, let's go back to here, is about there. 3 radians, and it's not quite right. I kind of messed up my markings, but you kind of get the idea that 3 radians, if 3.14 diameters gets us all the way around, 3.14 radians gets us halfway around. And if we keep going, here's about 4. This is 2, 3, 1, 5, it's about here. 6, I'm just saying there's 6 radians. And when we get all the way around, we're at about 6.14 or 6.28. 6.28 or 2 pi radians is a full circle. Now at 90 degrees, that's half of pi, or let's say pi over 2, which is about 1.57. And 270 degrees, or all 2/3 of the way, we take this 3.14 and add about 1.57, we get about 4.71, which is 1.5 pi, or 3 halves pi. And usually we'll write that like this, 3 pi over 2. So that's our radian measure. Again, it's how many radiuses how many radiuses on the circle, which is an arc, how many radiuses of arc we are on a circle compared to its radius. And it doesn't matter what the radius is, it's always, all circles are the same shape, and we always get this relationship. So when we're doing some of the homework, you're going to need to determine in which quadrant an angle lies based on its radian measure. Now to do this, I'm going to draw a circle again. Do my best. To do this, it's good to have some of these markers that I've made up here. We'll think of 90 degrees as pi over 2. Pi is equal to 180. 3 pi over 2 is down here. And this is 0 or 2 pi. Now 0 and 2 pi, these two radian measures, are coterminal. Let's put on here our degrees. 180, 270, and let's also put our approximations. 1.57, 3.14, this is about 4.57, 4.71 radians, and this is about 6.28 if we get all the way around. 0 degrees or 360 degrees. All right. So in the last video, we talked about, where does an angle lie? So let's say we have 3 radians. 3 radians is in, well, 3 radians is between 3.14 and 1.57. So it's about here. And that's a rotation counterclockwise. So that's in quadrant 2. If I had a number like 7, let's just say 7 radians, that's a little more than 6 radians, and 7 radians might be all the way around and then some. So this might be where 7 radians is. 7 radians. Now, let me pause for a moment. Now, 7 radians. Oops. Sorry about that. Having a little trouble getting my calculator into the screen. 7 radians. To figure out exactly where it is, I could say, well, 7 minus, and then a full rotation is 2 pi, and that's equal to 0.71. You get a lot of decimals if you're using your calculator, but the point is that this little arc here, 7 radians is about 0.72, is coterminal with about 0.72 radians. These are coterminal. And 0.72 is between 0 and 1.57, so that's in the first quadrant. All right. Now, a lot of times you're going to have angles in terms of pi, but they don't have to be in terms of pi. But if they're in terms of pi, generally we're speaking about a radian angle. And so we have an angle like pi. So here's pi. If I divide this half circle, which is pi, into thirds, I'm going to get an angle like up here. This would be, 180 divided by 3 is 60 degrees, but that's also equal to pi over 3. Okay. That's what a radian is. Now, determining, as I just to review here, to find a coterminal angle, I can add or subtract 2 pi. And we also want to be able to convert between angles and degrees, and that's an important part of this video. So let me talk a little bit about that. Get rid of this. Come back here. So let's start with, say I want to convert from, let's just say 30 degrees. And let's back up there. 30 degrees. We're going to write that as 30 degrees. And I want to know what that is in terms of radians. How many radians is that? Well, what I'm going to do is use unit analysis, and I'm going to multiply by a conversion factor that uses the fact that 180 degrees is equal to pi. This is our simplest relationship between radians and degrees, that 180 degrees is pi radians. Now I need to get rid of degrees, so think of this as being over 1. And I've got 180 degrees here. And that's equal to pi radians. So multiplying 30 degrees by pi radians over 180, I'm not changing the, I'm just, this is 1. This relationship is 1. It's a conversion relationship. The degrees are going to cancel, and what I have is that this is going to be equal to 30 pi over, well, 30 over 180 times pi. Now this, if I want to simplify that, I can divide out tens, and 3 over 18, I can divide out 3, and I get 1 over, and divide 3 into 18, 6, and that's, pi is still there, so I get 1/6 pi radians. Or, usually we'll write this as just pi, 1 times pi over 6 radians. Going the other direction, suppose I have, let's say 4 pi over 3. Now, if I want to multiply, or I want to convert, that's in radians, and I want to convert to degrees, I'm going to put the radians down below and degrees up top because I want to end in degrees. And this is 180 over pi. Now, note that pi cancels, and then I could say, well, 4 times 180, 4 times 180 over 3. And I could simplify this thing out. 3 goes into 180 60 times. 4 times 60 is 240 degrees. So 4 pi over 3, which, just to kind of say where that is, 240 degrees is down here. 4 pi over 3, and so on. And sometimes you'll have just a number like 2.2 radians. That's in the second quadrant. And I need to convert, say I need to convert it to degrees. I want to know really more comfortable in degrees, perhaps. Dig. Now this doesn't come out even, and so I actually will have to use my calculator and do the math on the calculator. And I would just say, all right, well, 2.2 times 180 and divide by pi. And you're always going to, in this class, whenever pi is in the calculation, use the pi key. Oops. Go to use the pi key, and I get about 126 degrees. So I think that covers this lesson for the most part. Just remember coterminal angles. To get coterminal angles with degrees, we added 360. To get coterminal angles in radians, we're going to add 2 pi. I'm not going to talk any more about that here, though, because the video is kind of run a little bit long. We'll stop here.